Hi, physical geology students. I believe we kind of left off on this slide. We were talking about coastal processes and erosion that occurs along the coast. Here's kind of just a block diagram showing you several features. We have basically the cliff face in the back here. We have the berm, which is the next closest part to the cliff, and then we have the beach face front here, and then it's showing here we have a high tide and a low tide being in this kind of this darker blue color, and then we have basically a wave cut platform here that's been eroded by basically by the wave action here. So here again, this is just showing you kind of an example of kind of the cliff face. You're going to have your berm here, and then you'll have your kind of your beach face here, and then you'll have your wave cut platform over in this area. So here's kind of a cross section of basically showing the migration of a sandbar. Up in this top image, you've got a short wavelength wave, and this is associated with higher energy. Here it's showing you here that as this wave approaches the coastline, you're getting more backwash, creating the sandbar deposit here. And in this lower image, you've got a kind of a longer wavelength wave with lower energy, and it's showing kind of how the sandbar deposit migrates landward towards the beach, kind of the beachfront. So remember we talked about the riptide and basically the backwash. This is kind of just emphasizing how these form as these waves hit the coastline. You have some rip currents that develop, and you get this backwash. And it's just showing you the water is basically sucked back into the ocean, and you've developed this kind of low bait feature here. And up here it's showing you what happens as the wave approaches, it breaks, and then it's sucked back by gravity, and you've kind of got this kind of low bait or kind of fan-shaped rip current that forms. And if you're in this area within the rip current, it can pull you back. And when I was in Rio de Janeiro, I experienced like the rip currents there. It's if you ever swam in the ocean, it's so powerful, and you have to swim. If you're going to swim out farther off a shore, you got to make sure that you swim parallel to the shoreline, just so you don't get taken out by the rip current. So yeah, swim at your own risk. So here's just emphasizing kind of the rip current, but you can see it here. So it's got the wave basically front here, or the wave surge. It's gonna come back, and it's gonna basically suck back. Here's your backwash. So it's very powerful current that's created from this. So longshore drift. I haven't got into that yet, talking about what longshore drift is. Basically, longshore drift is the process by which sand moves along the beach due to waves striking the beach at an angle. So essentially, it's showing right here. Here's the wave crest here, and essentially the waves are actually going to refract or bend towards the shoreline when they hit. So what happens is essentially basically you get more erosion of the beach, the coastline due to longshore drift. But anyways, the waves are refracted as they approach or are bent towards the coast. And here is kind of emphasizing, showing you here's a beach coastline. You can see the waves are breaking, or they're reaching their maximum crest here, and as they and as they hit the coastline, they're going to bend, and this is where your essentially the bottom part of the wave is dragging against the bottom of the ocean bed, and that's where that's where they refract and bend towards the ocean, the beach line here. And here it's just showing you here's where the wave touches the bottom here and slows, and then it's refracted or bent, and then it hits the beach, and then your current, your longshore current, is then parallel to the beach. So that's where you get a lot of erosion. Here it's kind of showing again, showing the wave front, and essentially here's the surf zone. That's where you get the waves break, and then here's the longshore drift. So the current is basically moves parallel to the beach face. So also we want to talk about the budget, the sediment budget on a beach, and this is all about kind of the balance of the system of with your inputs and outputs. So again, you're going to have your sediment inputs, and then you're going to have your sediment outputs. So the inputs are basically where do we get the sediment from? We're going to get it from rivers. We're also going to get an erosion of the cliffs. That's going to be an input. We're going to get sediment from upshore. So we're talking a longshore transport, and then onshore transport from deeper water. And then the sediment outputs, we're going to be getting sediment moves downshore. Sediment gets deposited in the backshore dunes, and then sediment gets taken out into deeper water, and this is the offshore transport. So we can look at these inputs and outputs and kind of try to balance the system. And here's just showing kind of, up here is showing the inputs plus the outputs is equal to a balance. And here it's giving you an example. Up here at A, we're going to include longshore transport into the beach, river supply, cliff erosion, and onshore transport. Over here are the outputs. So we're going to have your longshore transport out of beach, offshore transport, wind transportation into dunes. And what does this mean? Again, is it accretion, erosion, or is the system at steady state? And here it's just showing you an example of here's your output, and here is going to be your basically, I believe this is the W, which is going to be your wind. C is going to be your cliff erosion, some stuff off the cliff. O is going to be your offshore transport. Visa plus is your longshore transport into the beach. And here down here is your kind of they're getting into trying to quantify this. So here they're looking at your inputs, which are 60,000 cubic meters per year, and they're putting some numbers on here for an example, and then they're trying to balance it to see, is it positive? Are we gaining more sediment, or are we losing? Are we having more erosion that's occurring along the beach? So that's kind of an example. So they take that, what I've just showed you, they kind of take that and they can apply it to different coastal, different coasts along, in California, or for instance, maybe in Rio de Janeiro, wherever there's a lot of tourism, because that brings in a lot of money, for the country or for the state. Anyways, this is showing the Southern California coastline here, and they're showing that basically here that that the sediment is dominantly sourced from the rivers, and it's also secondary from the cliffs as well. And then a lot of the sediment is lost to submarine canyons, which are also near the shorelines here. So there's basically both primary and secondary aspects you're gaining from your sediment. And sediment is lost to submarine canyons, and for instance, here is showing you a canyon, an offshore canyon in California that was produced by Instar in Colorado, and it's showing you all these actual canyons along the shores. And this is where a lot of the sediment goes from the beach. A lot of it's kind of funneled towards these canyons out into the ocean. So what I'll do here, I'll stop right here, and I'll resume back here next time here because we're over our 10-minute mark. So thanks a lot. I'll talk to you guys again. Bye.